Good morning, distinguished speakers, researchers, and participants of the Frontier in Sustainable Agro-Maritime and Environmental Development Conference 2025. My name is Belina Unitasari from the Department of Mechanical Engineering, Universitas Negeri Surabaya, Indonesia. It is an honor to present my research titled Performance of Natural Plant-Based Inhibitors, Effect of Psidium guajava Extract Concentration and Immersion Time on Corrosion Rate of Boiler Tubes. This study aligns with the global push towards sustainability by exploring natural, eco-friendly corrosion inhibitors that can potentially replace synthetic chemicals widely used in industrial systems. Introduction. In this slide, I introduce the fundamental problem addressed by the study. Boilers operate under high temperatures and are constantly exposed to water, oxygen, and chloride ions, making them extremely vulnerable to corrosion. This corrosion not only reduces system efficiency, but also shortens equipment lifespan and increases maintenance costs. Organic corrosion inhibitors offer an attractive solution because they are effective, inexpensive, and environmentally friendly. Guava leaves, or Psidium guajava, contain tannins, natural polyphenols, known to form protective complexes on metal surfaces. Although several studies have shown the potential of guava leaf extract as a corrosion inhibitor, its application to boiler tube materials in chloride-rich media remains limited. Therefore, this study focuses on investigating how inhibitor concentration and immersion time influence corrosion using the classical weight loss method. Methodology. This slide describes how the research was conducted. We began with the preparation of guava leaf extract. 2 kilograms of fresh leaves were washed, dried, blended, and sieved before being macerated in ethanol for 48 hours. The filtrate was concentrated using a rotary vacuum evaporator at 78 degrees Celsius, ultimately yielding approximately 59 grams of paste-like extract. Next, we prepared 60 steel coupons cut from boiler pipes, measuring 30 by 20 by 4 millimeters. These samples were sanded to remove contaminants and washed thoroughly. To confirm the presence of tannins, we conducted a phytochemical test using FeCl3, which produced a dark green coloration indicating tannin-iron complex formation. For the corrosion experiment, a 4% NaCl solution was used as a corrosive medium. The samples were immersed under varying inhibitor concentrations, 0, 500, 1000, 1500, and 2000 ppm, and for immersion periods of 3, 5, 7, and 10 days. After immersion, weight loss data were collected and converted into corrosion rate and inhibition efficiency values. Results and discussion. Now, let me walk you through the core findings. The corrosion behavior observed is governed by electrochemical interactions between steel and chloride ions. At 0 inhibitor concentration, 0 ppm, the corrosion rate was the highest. This is because chloride ions aggressively attack the exposed steel surface, breaking down passive layers and accelerating metal dissolution. As inhibitor concentration increased, the corrosion rate consistently decreased. This is due to tannins and other polyphenols in the guava leaf extract absorbing onto the steel surface through their oxygen-rich functional groups. These molecules form a protective organic layer that blocks access of chloride ions and water. In addition to inhibitor concentration, immersion time played a major role. Longer immersion resulted in lower corrosion rates, indicate gradual thickening and stabilization of the protective film. However, at very high inhibitor concentrations, slight deviations occurred due to partial desorption or oversaturation, resulting in a less compact film, as reported in similar studies on plant-based inhibitors. Overall, the trend reflects a competition between chloride-induced corrosion and the protective adsorption of tannin molecules, consistent with Langmuir-type adsorption mechanisms. Immersion times improve corrosion protection until the adsorption layer reaches a saturation point. Too high inhibitor concentrations may cause desorption, reducing film compactness and inhibition performance. The overall results demonstrate that guava leaf extract is a promising eco-friendly corrosion inhibitor suitable for boiler tube applications. For future work, it is recommended to test corrosive media and temperature conditions that better simulate real boiler environments, and to explore a wider range of immersion times and inhibitor types. Acknowledgement. On this slide, I would like to express my deepest appreciation. This research was made possible through the facilities and support provided by the laboratory of Universitas Negeri Surabaya. I would also like to sincerely thank Universitas Negeri Surabaya, UNESA, for the financial support that enabled this study. My gratitude also goes to colleagues and academic staff who assisted with sample preparation, laboratory work, and discussions throughout the project. Thank you very much for your attention. It is my pleasure to share this work at FISED 2025, and I welcome any questions or discussions. You may contact me at bellinaunitasari@unesa.ac.id.